Okay. So it won't take much time. It take like hardly like 40 minutes of time or 30 minutes, not more than that. Okay. See, indexes, see, index. If you have some textbook, we are maintaining some index space, right? See, why we are maintaining that index space for textbook, right? The textbook, the index space indicates what the topic is located in which space. Okay, so so the required topic is located in this particular place. So this topic is from this position, this page to this page. So that information we are keeping that in a index book. Sorry, index page. Correct. The same way, while inserting the data into the table, select start from EMP. See, if you observe here, Smith is located in, if you are trying to get the data for Smith, the Smith is located in the second position, right? So if you are looking like a Scott information, he is located in the ninth position. See, if I am allocating some number for that, 1, 2, 3, like that sequential number, instead of searching with values, I am searching with the address ID. See, he has some, see, everybody having their own name, but we have some other ID for each and every member. So why, like they allocated some other number for easily identification the people. So if you have your other ID, so you can get so the government having your like all information about you, right? See, if you are searching with Aadhaar number, so you are directly getting the person for me. So if you are searching with name, see the same name persons may have multiple members, right? In such case, I want to filter it out from out of those all people, correct? See the same functionality is going to work here. How that index space is working to reach your destination topic fastly. See, now you are looking like a constraint topic in Oracle book. Think. See, in such case, the Oracle constraint topic is located in a 40th page. You have like a 120 pages of textbook or a notebook. Now you are trying to reach 40th page, right? See, if you have the index page, you know this 40th to 45th page is a constraint topics is located. In this case, what you will do, you won't go like a page by page from starting zero page to first page to till 45 page, you won't go like that. See, 40 page in the sense you will keep in mind 40 page in the sense this much of papers will have to rotate at once. See, you can rotate bunch of papers, not like a one paper. So you will like a rotate the papers, bunch of papers like it may be bunch in the sense it may come like a two, it may come like 40 pages, it may come like 20. You don't have option to go directly into that particular page, right? See, in this case, you are performing range of such operation. You are not searching page by page such operation on the textbook. If you have the index page, if you don't have the index page on your textbook, you want to search the constraint topic from first page to last page. Even if you found that required topic constraint in the middle, so you have to search maybe the constraint topic is located in another pages as well, because that is not in order. That is not in order. See, if you are creating the index page, all the constraint topics, all the functions topic, you are keeping in order of place. Related of anything about constraints, you are keeping from one page to another, like 10th page to 50. So whatever it might be. So the location you fix for that. So in that particular place only that page will be located. See, yes, you are keeping finance data types. Then we have That's process. Something we have. See, if you are maintaining that constraints. Okay. So if you have this type of textbook, think like these are we have only 6 topics in that. Now you are maintaining the commands related information. So you are sorting that all command related information from 1 to here you are keeping 1 to so 5 page numbers. Okay. Then you are keeping data type information. So 6 to 7. Then you are keeping. See, if you are searching for data types, right? You may come from first to till 7th place. So if you are like your search operation is going beyond the 7, the search operation is going to stop where we have the index, where we have the index. See, so ikkadaithe ఈ index space నీకు see if you are maintaining the index space, you are ordering all topics together in particular order and you are making the page numbers like this, right? If you are searching the commands information, see if I started from starting, max the pages is 5th page. If I am reaching beyond the 5th page, the commands is not available for other pages, right? See, up to the commands information is available up to 1 to 5th page. If the search operation is going beyond the 6th, I mean beyond the 5th, the search operation need to be stopped. సో ఎందుకు సో తర్వాత కమాండ్స్ రిలేటెడ్ ఇన్ఫర్మేషన్ ఎక్కడ ఉండదు అనమాట దాని గురించి. సో వీ హ్యావ్ టు స్టాప్ ది search operation here, right? If you don't have the index space, if you don't have the index space, just you mention the comments topics here. So the comments you may found like if you have 1 to 40 pages of a textbook, if you found the comments topic, so commands topic in 10th page or 3rd page. Okay. See, your search operation need to be continued till last page, because we don't have information. You are maintaining that topics wise the data or not. If you are maintaining the topic wise, you have to maintain the index space for that. Then only I know. So if we have the index space for any textbook, definitely the people will know all information about the commands is available 1 to 5th, right? So operators is available after 7th page, right? You may guess that you will reach your required topic very fast. The advantage of index is simple. So indexes help you to reach the destination topic in the textbook, whereas in the data case, indexes will help you to retrieve the data fastly. See, data, while retrieving the data, what is happening here? So if you mention select star from EMP, so here you are not searching anything, you are blindly displaying all the data from your table. Now what I'm going to do, where employee number equal to 7902, I'm searching now. Out of 15 records, I'm searching some information. So employee number equal to 7902. So I want to search. If you don't have the index, so what will happen? See, here it takes the employee number of each record. 15 records we have. 1234 equal to 7902. 7369 equal to 7902. It compares each and every value. Here you found like a 7902. it search the another record as well, because you don't have the index ID. Maybe 79 another 7902 is also present in the next of that particular record, right? In case if you maintain the order, the index for that particular record, if you maintain the index for in employee number, if you create the index for this particular column, so what will happen? What will happen? See, okay. See, just I'm creating some list and it understand the data. Okay. So 156782358. Something like we have this data. Now, if you are storing this information, so if you inserted the first is first, the data is in the first record will be the first. Fifth record is in the second position. Sixth is in the third position. Right? If you create the index, if you create the index for this, if you create the index, the data is going to sort at the back end. The data is going to sort. So how we have like I said IoT tables, we have index organizer table, correct? See, in that particular format, it is going to convert. In this case, what will happen at the back end? I'm saying so it convert that one, then two, three, then what we have five, five, then six, six, seven, eight, eight. So three, nine records, three, nine records. See, it's a normal data. Normal data. It's a indexed data. Indexed data. If you create the index for any of the column based on that particular column, I'm going to sort the data at the back end. I'm creating some copy of data. It won't maintain physically anywhere in the database. Just it creates some address IDs for every record. Address ID in the sense index ID for every record, and it sort that information and keep that in sorted order. Right. So what we discuss about IoT table, if you are inserting the data A first, the A is in the first position. If you are inserting like a Z in the second position, that will be in second position for that till that second place. If anyone is inserted A value again, the Z value is come under last record, right? The data is going to sort and the results also getting sorted and stored that as per the sorted order. It may be ascending or descending. Here in this case, if you create index for that particular column, employee number, if you create a employee number index, right? So what will happen? It's going to sort the data and keep that results in this particular order. In this particular order. Okay. So while searching this, if you are searching for 7566, right? It starts from the first record to till this 7566. If value is going beyond like a 7566, like a 7567, the search operation is going to stop. It is performing range of search. It's performing range of scanning mechanism. See, the search operation we are calling in the Oracle scanning. It performs the range scan. If you observe here, if you want to know, so how to know that whether it is performing a range scan or it is performing like a full table scan. So in the sense, it is going for full table search operation or it is going for a part of the table operation, we can see. See how we are going to see that information. In the SQL developer, we have simple option. Simply, if you press like F10, you will get a explain plan. See, if you see here, you run the select statement. If you observe here the table access. See, what the object table, what is the table you are accessing? EMP options. If you observe here, it is going for full table scan, full cardinality. So what is meaning of cardinality? What is meaning of cost? We'll see. We'll see. I'm pinning this in result. Okay. Now I'm using another query with where condition. Here you are blindly displaying all the data, whatever the data we have in the table, you are blindly displaying that without applying any conditions. Now I am applying the condition here. Okay. Now I am running with the F10. Okay. Now also it is going for full scan. See, to display 14 records, also it is going for full scan. To display one record also it is going for full scan. Right? If you see here, cardinality it is giving 1. If you see here, cardinality is 14. Cardinality is 14. See, what the meaning of cardinality? See, in this particular employee, we can say, just one second, it is getting confused with this. Select from EMP where employee number equals to 1, 2, 3, 4. See, cardinality in the sense, distinct rows of the result. Distinct rows of the results. Here it is, here our table is having 15 records, but the query is saying only 14 records we have. Cardinality, if you observe, the cardinality is saying only 14. It's a wrong. See, wrong in the sense how it is saying wrong. See, manamu government మన పాపులేషన్ ఇన్ఫర్మేషన్ ని గ్యాదర్ చేసి స్టాట్స్ మెయింటైన్ చేస్తారు. సో యంగ్ మెంబర్స్ ఇంత ఉన్నారు, చైల్డ్ మెంబర్స్ ఇంత ఉన్నారు, ఓల్డ్ ఏజ్ పీపుల్ ఇంత ఉన్నారు అని చెప్పి ఒక గ్రాఫ్ ని రిప్రజెంట్ చేస్తూ ఉంటది ఇయర్ వైజ్. ఓకే. సి ఇయర్ కి మధ్యన చాలా మెంబర్స్ ఎక్స్పైర్ అయి ఉండొచ్చు, లైవ్ అయి ఉండొచ్చు, న్యూ మెంబర్స్ బార్న్ అయి ఉండొచ్చు, ఓల్డ్ మెంబర్స్ ఎక్స్పైర్ అయి ఉండొచ్చు. Right? See, while displaying the data from last year to till this new data gets, in between you are giving the wrong information. You are not giving the correct information. So you are not maintaining the stats day to day. So I mean, you are not maintaining, you are not updating the stats information day by day. Right? Every day you are not updating the stats. You are maintaining the stats information on a yearly base or half yearly base, whatever it may be. Till that particular place from one like one So population information to gathering of another population information, there is some gap, right? Now the table is also having the gap. So you have to take stats of the table. So how you are gathering the stats of the population. The same way now I need to gather of the table stats. See how to gather of the table stats. So stats in the sense how many records we have in that particular table, how many distinct records, distinct records. So if you are look like a the jobs, how many distinct jobs we have in this particular column, right? If you added new job here, so while looking the information about this particular job, so I want to display so the new job as well the later. So how, where we can get that stats information? See, if you describe the table, open declaration, I'm going here. If you see in the details, so we have some option like a details. Okay. See, the table got created on 22nd July. Last DDL happened on 22nd July. Table name is EMP. Table owner is XDB. Table space name is this. Okay. Sys AUX. See, status, the table is in a valid mode. You can use this. Okay. See, last analyzed. You have to check. Logging. So, logging, you know, right? If you are running anything about, if you are running any query on EMP table, so Oracle will maintain the logs for that because you enable the log for that. Okay. See, you have to analyze the column name, something you have to check. Table analyzation. Okay, so I'm going in the directly table in user underscore tables. I will get that. So let's start from user underscore. Last analyzed. Last analyzation when happened, you can check in this. See, last analyzation happened at 23 July, right? If you maintain, simple, if you want to maintain that, if you analyze the stats now on the table, okay, simply so analyze table, table name EMP compute statistic. If I use this, the table has been analyzed. If I refresh now, we will see that table analyzation happened for today. 25th July, right? Now you can try to gather that stats on your table. So let's start from this. See, cardinality has changed. Now it is showing 15. See, in this starting of the time, it is showing 14. It giving wrong information for you, right? While retrieving the data on the table, the stats is not updated. In such case, also you are going to get some performance issues. సో ఎప్పుడైనా నువ్వు టేబుల్ పైన వర్క్ చేసేటప్పుడు ఆ టేబుల్ కి నార్మల్ గా నిన్నటి వరకు ఎస్టర్డే యు ఆర్ రన్నింగ్ సమ్ క్వరీ, ఇట్ ఈస్ టేకింగ్ 1 minute ఆఫ్ టైం. Today you are running this query, it is taking very long time. It may be 1 hour of time, 2 hours of time. The query is not coming out of execution process. See, alanti case vachinappudu, you have to be careful. What are the tables we are using in that particular statement? Or what are the tables you are using in that select statement or update statement, delete statement, whatever it may be. So take the table, take each table and analyze and compare like a, so when the table analyzation happened, so you have the table stats for as on date or not. See, as on date నీకు ఉన్నావు అంటే you have like a proper stats for the table, you are getting the correct information. So you maybe you have the huge information or something else, you can guess and you can do that. If you don't have the proper stats for as on date, meaning you have like a 2 days back, 23rd July stats for our table, right? So from 23rd to till now, in between, some person has applied bulk of DMLs or huge DMLs. So ఏదైనా ఒక టేబుల్ పైన మోర్ నెంబర్ ఆఫ్ రికార్డ్స్ ని అప్డేట్ చేస్తా ఉన్నప్పుడు, see here we have only 14, 15, tens of records. If you are working in banking domain, you will see the millions of data per day. Per day. I'm not saying like a whole. Per day you will get millions of data. Crores of transaction you will get. You have to push that into the table. While pushing the data into the table, so you have to, after pushing the data into the table, you have to maintain that stats. Else, it maintain the yesterday's table information. So if you are not maintaining that, it is going to give performance issues. Okay. See, elanti issue vastadi ante, if you see, how take like a banking project. So till yesterday, I have 1 lakh of deactive accounts, 99 lakhs of active accounts, right? See, today what you did, you updated active equal to inactive, inactive equal to active. You updated that information. See, now I'm trying to retrieve the data. Select star from account table where status equal to inactive. ఏమవుతుంది, నిన్నటి వరకు ఏమైంది, నిన్న నువ్వేం చేసావు, యాక్టివ్ ఈక్వల్ టు 1 lakh కాబట్టి, సో నీకు చాలా తొందరగా వస్తుంది డేటా, 1 lakh డేటా కాబట్టి. సో ఈ రోజు ఏమవుతుంది, నువ్వు 99 lakhs ని నువ్వు డేటాను రిట్రీవ్ చేస్తావు. సో సిస్టమ్కి అది తెలియదు, నిన్నటి స్టాట్స్ ఉన్నాయి కాబట్టి దాన్ని బేస్ చేసుకొని ఇందులో ఇంత టైం తీసుకోవాలి అని చెప్పి అంత టైం ఆ క్వరీ రన్ అవుతూ అలానే రన్నింగ్ మోడ్లోనే ఉంటుంది క్వరీ. సో ఇట్ వోంట్ కమ్ అవుట్ ఆఫ్ ది ఎగ్జిక్యూషన్. ఎప్పుడైనా మనం రన్ చేసేటప్పుడు SQL డెవలపర్ స్ట్రక్ అవుతుంది. ఆ స్ట్రక్ ఎందుకు అవుతుంది అంటే క్వరీ ఎగ్జిక్యూషన్ ప్రాసెస్ లో ఉంది, అది స్ట్రక్ అవుతుంది అనమాట. అర్థమవుతుందా? సో అదే నువ్వు if you updated the stats for that particular account table, then it will come fastly. Till now clear? See, these are all the story, but you will get the interview question. See, you will get the interview question. So I have some query, the query is running till yesterday, fine. So all of a sudden it is giving the performance issue. So what are the steps you are going to implement to prevent that performance issue, right? See what the issues you are going to apply. See what the steps you are going to follow to overcome that performance issue. First, I will see the explain plan for that particular statement. I will see the explain plan for that particular statement, and I can observe. See, if you have more tables in that, so what are the table is going for full scan? What are the table is going for range scan? I can observe all the things. See how it goes for the range scan. If you see, simply I'm creating index. Create index IND 1 2 3. Just I'm keeping the Naming convention I'm not following here. Just I'm mentioning some default name. So whatever maybe. So index 123 on EMP of employee number. I created index. For fetching one record, it is taking long time for you, right? I mean, cardinality, it is fetching only one record. For fetching the one record also, it is taking 3 bytes of things earlier. Now I am trying to retrieve F10. See, table access EMP, it is going for by index row ID. It is going for range scan of this index. Whatever index you created, due to this, it is not performing the full table scanning mechanism. It is performing the range scan mechanism. See, if you see here, cardinality is 1. Cost, it reduced 3 to 1. Sorry, 3 to 2. Right? For one record, it reducing like a 30% of usage. Correct? See, if I have any query, the query, if you have handy, if you know that particular query is giving the problem, I can take that particular query and I can see the explain plan. See, this is not the way to explain. If I click F10, I will get the explain plan. Explain plan. This is not the way. We have to write some query, explain, plan for whatever the statement I have that I have to take and I have to see that. Okay. For which query you are expecting that explain plan. Explain plan in the sense, see here, we have the index scanning. Okay, so now I'm explaining the, see here, query has been explained. Explained in the sense, explain plan is nothing but it's a prediction of how the query is going to execute. See, if you want to travel from X place to Y place, right? If you want to travel from X place to Y place, you will see some directions. If you go right side route, you may reach in 10 minutes. If you go straight, you will reach in 5 minutes. If you go with right side, see, you may have like multiple ways to reach your destination. You won't follow the single route. You will follow multiple routes to reach our that destination. While reaching that, whichever the route is giving the less time, that you have to choose. Right? See, if you go, the Google map is giving the directions for you. If you go with this way, you will get this much time. If you go with this way, it is a prediction of journey time. The same, it's a prediction of executing of the query. If you execute this query, what would the memory I'm going to take, what the memory I'm going to use here, for how many records, to process how many records, how much memory I'm using here. See, if you see, the cardinality will indicate how many records you are working with that particular statement, how many records it retrieving or displaying, okay, or processing with that particular statement. It's called like a cardinality. How many distinct records you are working in that particular statement is cardinality. Then we have cost. To process or to retrieve one record, you are taking like a 2 bytes of memory, 2 bytes of memory in a CPU. Your server is having CPU. Your server is having, see, if you are running the things in this particular session, in the first session, it has some session ID for that, different session ID for that. See, not now, we'll see that later class. No, not now. Okay, in the PLSQL, we'll see. See, in computer, we have multiple instances. Multiple instances in the sense, if you are running the statement in this particular session, it allocates some session and run that session in that particular, so run this query in that particular session. So for this, we have another session. For this, we have another session. So we have multiple instances in the server. CPU, see, in personal computer, we have only one CPU, right? Whereas in the server case, we'll maintain multiple CPUs inside of the server, right? Inside the CPU, we have multiple instances, rack. So Oracle supports rack database. So rack indicates if you want to run single query, right? If you are running like parallelly in two sessions, right? You have only one CPU. If you are doing one task, you cannot able to do parallel work to in same time, right? See, the human can able to do only one work at a time, right? Your personal computer or whatever it may be, your computer can able to do only one task. If you are typing it, you can able to do only the typing. If you want to watch the movie together, you can do that now. So your computer is having the sessions. So session CPU is having like a multiple, it split that one session, one CPU into multiple racks. And if you are working any task, it allocate one rack for that, not the rack, it's session. We'll call it as a session. The DBA people will call it as a rack. Okay. So now it indicates, now the plan has been explained. It's a prediction of execution of that particular statement we will get by using the explain plan. In the explain plan, you have to observe here cardinality in the first case, then the cost. Then we have to see in third case, we have to see here scanning mechanism of the tables. Scanning mechanism of the tables. See, the scanning mechanism indicates whether it is going for full scan. We have to avoid that full scanning mechanism. We have to avoid that full scanning mechanism. Now simply I'm dropping it and I'm recreating that index. Now it is going for full scan to retrieve only one record. It is taking 3 bytes, right? Now I'm creating the index on top of this. Now I want to avoid this EMP table full scanning mechanisms. How we are going to avoid? Simply by creating of indexes. We can avoid that scanning mechanism. So nowadays it is taking only 2 bytes, not 3 bytes. Right? Okay, so now this will help you to improve the performance. So what performance it is improving? It improving the data retrieval process, or it improving the select statement performance. So you are writing the condition in the select statement. So that's the reason what the select statement indicates. It opens the data from the table or it retrieves the data from the table. So that's the reason I'm saying indexes will improve the performance of select statement, or indexes will improve the performance of data retrieval. So better you can call it as it improve the select statement performance. How it is improving? If the select statement is having any where classes or where conditions, if you want to apply the conditioned columns, if you create index or if you apply the index from the condition columns, it retrieves the data fastly. Clear? Now, so in the earlier, if you don't have the explain SQL developer, so how we are going to get the explain plan information? Okay. See, you see here, what are the things you got in the shortcut? The same thing, select statement. So number of rows, how many rows? You are fetching only one row. To run this, it is taking two CPUs, 2 bytes of things. Okay. And it is going for index range scan. See, predicate information identified by so operation ID. See, if you are running the statement first time, see, if you are traveling from X place to Y place, if you are not aware of that particular route, so in the starting time, you have to follow the Google instructions and you have to travel. So it took like a 15 minutes of time. The second day you are traveling, right? See, you no need to check the Google map again and again. So you already went in that particular route. So you are aware of the route now. You can travel without following the Google map. So what I'm going to say here. సో నీకు ఒక రూట్ తెలిసినప్పుడు ఆ రూట్ లో నువ్వు ఎలాగైతే ఫాస్ట్ గా వెళ్తున్నావో సో అలానే ఒక క్వరీని నువ్వు డేటాబేస్ లో రన్ చేసేటప్పుడు ఆ క్వరీకి ఎన్ని రికార్డ్స్ ఉన్నాయి అందులో ఎంత టైం తీసుకుంటది ఏంటి అని చెప్పి నీకు ఎక్స్ప్లెయిన్ ప్లాన్ చేసినప్పుడు ఆ ప్లాన్ యొక్క వాల్యూని ఒక నెంబర్ తోటి స్టోర్ చేసుకుంటది సో దట్ వాల్యూ వీ కెన్ కాల్ ఇట్ యాజ్ హ్యాష్ వాల్యూ ప్లాన్ హ్యాష్ వాల్యూ ఓకే if you are running the same statement again and again it displays the same plan id for that now I am explaining it again okay so what we have here 056 correct I'm explaining the same query again and I'm trying to retrieve 056 correct now I'm changing with the different statement so what we written 7566 huh? Now I'm changing with the 7566. Now I explained. Now I'm trying to retrieve the wait. Wait, I'm changing that into department number equals to 10. See, now the hash value has been changed. If you run the same statement again and again in the database, it created some path or it created some plan to travel from X to Y. It follows the same route because it gives best route for you. See, ఎప్పుడైతే ఆ బెస్ట్ రూట్ లో నాకు ఏదైనా ట్రబుల్ వచ్చింది ఇఫ్ యూ హ్యావ్ సమ్ బ్రేక్స్ ఇఫ్ యూ హ్యావ్ సమ్ స్టాపింగ్స్ లైక్ the traffic police has been stopped, the traffic has been jammed. In such case, I will take another route, diversions. The same thing is happen here. If the plan while traveling, if you get the trouble, I'm going to choose the different route, right? See, this we can call it as a explain plan. How that really executing that traveling, it's a execution plan. It's a explain plan is prediction of execution plan. Explain plan is a actual execution of thing, how that query is executing. That also we can see in the next class. Next in essence in the PLSQL thing. Okay. So simply if you click like set auto trace on, so auto trace on, give actually. So this we have to explain in a command prompt. So we'll see. So plan table output, okay, shows the execution plan as well as a statics of the statement. To execute this, to display three records, what happened is unable to gather stats. Please ensure user has correct access. So we are missing some grants here, so we have to look it. So I will take the necessary privilege. I will apply necessary privileges and I will explain about in the next class. Okay. So now we'll see what is index, what type of indexes we have. We'll see first. Okay. So this you have to remember these two things. Explain plan for. If you don't have the explain, see you can't say like by using F10 you will get the explain plan. How you are going to get really. So that you have to explain. This is the way. So these are all the our comfortable. The people has introduced the third party tools. It's not the Oracle command. Okay. Now, now see at least take some screenshot of this. Okay. So now we'll see. Index is helping to reach the or to get the data fastly. Okay, correct. The definition is that the syntax of this create index name, create index name. Okay, create index name on table index name on table of column name. Okay, table of column name. See, I am creating the index user is a okay. Create index name is IDX user is the index name on table users of city column. For city column, I am creating the index here. This is the syntax. Here I mention the table space name. See, if you create the table is going to store in a default table space. If you want to create the table and store that particular table information in the like different table space, our own table space. If you want to maintain special table space for particular tables, in such case, see select star from user underscore table spaces. We have these 4 table spaces, correct? Now I'm going to create the table in XTB. Create table TT. C is the column name and number. Okay. Now I created the table. Check the table is located in which place. User underscore tables where table underscore name equals to TT. Table space name is sys AUX. This place we have. Now I can create the table in system table space. Okay. So now I'm creating the table with the table name. Okay. Now I created the table by mentioning of the specific table space name. Now, if you observe here, the earlier the table is located in a sys table space, sys AUX. Now it is located in a system table space. So this will help you. See, instead of keeping all cloths in one box, if you keep like a shirts in one box, I mean you can keep multiple racks in your box, and you can keep each category of cloths in one place. So while retrieving that, it will give fastly, or while taking that out, that will help you to get the data fastly. Right? The same way, instead of using common table space for the tables, so where you are using like where it is important data you are keeping. Keep that important tables are daily usage tables where you are applying huge load on the table. Keep the tables in different table space. So that will help you somewhat performance improvement. Any doubt on this?
Anna, can we create table spaces?
Yeah, we can create. That's not our job. We can create. Yeah, after completion of SQL, we can create our own database also if you need. Okay, I can prepare the script and I will provide you all, or we can create by our in the class itself. Okay,
Okay, Anna. Okay, Anna.
we can create. That's not our job actually. If you want to create, we can create.
Okay.
Okay, now, so this is also one thing you can explain. So how what the techniques you are going to apply. So I can maintain where I'm using like instead of keeping like all the table information in one table space, I can maintain separate table space where we have like a huge bigger table where we are performing the huge DML operations such kind. Okay. Now so this is about syntax of index, correct? Now we have types of indexes. Okay, types of indexes. See, we have B-tree index, bitmap index. See, where we have the column, see, we are applying the indexes on the column, right? That particular column is having more than two distinct values. If you see here, the EMP table is having 14 records. If you check for a if you check for any of the column is having greater than two values, any of the column, distinct values I'm saying, right? So in such case, I will use the B-tree index, B-tree index, right? Here we have less values like a gender value we have. Gender, what you will see, male, female, active, inactive, status, active, inactive, right? So the column should contain only two distinct values. For those columns, I can create the bitmap index. For those columns, I can create bitmap index. So where you are having more than two distinct values, that we can call it as a high cardinality column. See, cardinality in the explain plan, we are seeing the cardinality value, correct? The cardinality in the sense. So whatever the condition you mentioned here, employee number equal to 7902. So it indicates only one distinct value in that results. That's the reason it is showing like a cardinality is 1, right? If the cardinality is high. See, that particular column is having more than one distinct value. So such column we can call it as a high cardinality column. Sorry, more than two distinct columns. Okay. If you have only two distinct values, we'll use bitmap index with low cardinality. So it's a low cardinality column. So we'll use the bitmap index for that. So how we are going to create B-tree index? So simply how we created index, create index name. It's a B-tree index. B-tree index. See, we are creating heap tables. We are not mentioning create heap table. But while creating the temporary tables, we are creating create global temporary table, right? We are mentioning it. So if you are not mentioning, this is the heap table. The Oracle knows that. The same way, if you are not mentioning what is this index, Oracle treat this is a B-tree index. B-tree index. Clear till now? Now I'm dropping this index. Now I'm trying to create. It won't give any trouble. If you create bitmap index also, it won't give any trouble for you. Create bitmap index. Create bitmap index. Just you are mentioning that index type here. It won't give any trouble for you, but it won't give as expected results. Now the cardinality is went for more. It is showing 5. Right? No use of creating the for high cardinality columns. If you create a bitmap index, that won't help you. That is going to cause performance issues again. Clear? Now, this is the two important things you have to explain in the interview. B-tree, bitmap. What is index? What type of indexes we have? Then, is there any other indexes in Oracle? Yes, we have another indexes. Another indexes. See, now I'm dropping this index. How I mention the bitmap? The same way I'm creating another index. Create unique index. Create index, create unique index. Both are the normal B-tree indexes only. So unique index also come under B-tree index. Right? See, it improves than the normal index. Than the normal index. See, it just like as Aadhaar number of every record. If you have the Aadhaar number, no confusions, I can easily catch you. If you have ration card number to catch you, so what are the family members you have in that ration card? I have to catch every member, then only I can catch you. Right? It's a range. Ration card is performing or a white card is performing the range of such operation. Right? Aadhaar card is performing the, like what we can say, it's an NQ scan. It performing NX scan. See, check now in the cardinality for employee number equals to employee number equal to 7902. Okay. Now I'm explaining the things and see that in this. It's going for index NX scan. You observe here the mark also got used 0 bytes. Here it is taking 1 byte here for normal index. Now it is taking less than one CPU. Clear? So Inix scan, the name itself is having it maintains the unique IDs for every record. It won't store anywhere in the database. How we have like a row IDs. So row ID is also physical address record, physical ID of physical address ID of any record. Correct? Same way. Now, is there any other indexes? Yes, we have another indexes as well. See, okay. See, the user wants to retrieve the data. Okay. Select star from EMP where E name equals to Smith. Smith is present in a table, but data is not in a Data is not in a, just one second. Okay. Now here I'm selecting the data from EMP table, right? See, Smith is present in my table, SMITH. See, the user may apply or enter the information in the capital letter, in the small letter. So I'm not aware of how the user is inserted the data into the table, right? So whatever the format I'm sending, okay. So the user is while fetching the data from the table, the user sends the data in the lower case only, lower case. The user may store in the lower case. The user may store in uppercase or initial letter in caps, right? While retrieving it, whatever the format we have in the database, I won't look for that. So whatever the format I'm applying, I need to retrieve the data. So I don't want to say any reasons. You mentioned the wrong format, you mentioned wrong this, like that. So I am going to provide the inputs in the lower case. You have to retrieve that stored information in the capital letter or lowercase or init cap, whatever it may, whatever the format, you have to retrieve it. To retrieve that, we have to display or upper or lower, whatever it may be. So you want to lower of ini equals to, here also you want to mention, you can use lower of ini. You can send any format. The user is stored with any format, I don't care. I'm matching with the same conversion in both places, right? In this case, I'm creating the index on the, I'm creating the index. Now I am mentioning the value. I'm restricting the employees to provide that input as a lowercase. Okay. Now I'm creating the index on employee name, e name. Sorry, I created unique index here. So I'm creating the normal index. Let's apply. Okay, so ename equals to Smith. F10 is performing the range scan, right? It is, you are able to get the data on like a character data type columns also, right? Now it is working fine. Here the same, the ename is having index, right? I'm using that column in the where class, but I'm not using directly. If you observe here, see now the table is going for full scan instead of going with normal scan, sorry, range scan, right? In this case, why it is going for, see, what are the things I provided? See, who founded that anything like, a plus b whole square formula. See, a plus b whole square equal to, so a square plus b to a square plus b square plus 2ab. See, the formula is fixed. If you are, see, the formula is fixed, just you want to change the values and you have to apply the same rules, right? You are changing like a square plus b cube plus 2abc, something if you do, right? It's a wrong thing. The same thing, I created the index for the standard alone column. If you are using this column as a alone without applying of masalas, like how you applied this lower function for that column, right? If you use direct column in the where class, it won't give trouble. So it works as expected by you. If you are applying any column, it gives the trouble for you. The index usage won't be happen here. index usage won't be happen. See, in this case, instead of creating the normal index, you can take the, you can create the, you can create the upper of a name. Now you can check that. So what we mentioned, upper or lower? Here I mentioned lower only, right? So what are the function you created as a while creating of index? You can use that directly. Okay. See, now it is going for range scan. So we have B tree index, bitmap index, unique index, function based index. Okay. It is about indexes. We'll see some more detail while in the performance classes. Okay. So I'm going to stop for today.